Hello everyone, I am Professor KINEMATIcs. In this session, we are going to study the kinematic analysis of the epicyclic gear train. In the last lecture, we have studied the what is mean of epicyclic gear train, how that epicyclic gear train works, and what is the principle. Because of this, we can transmit the or we can achieve more velocity ratios in the compact space that we have studied. Now, in this lecture, we are going to study how to do the kinematic analysis of the epicyclic gear train. Especially in this session, we are going to study how to use that tabular method to do the kinematic analysis of the epicyclic gear train. The objective of this session to aware the student about the kinematic analysis of epicyclic gear train and to know about the how to do or how to use that tabular method to do the kinematic analysis of epicyclic gear train. In the epicyclic gear train, there are the three members. One is the sun gear, second one is the arm, and third one is the planet gear. Sun gear which rotates about its own axis. Arm which consists of the two ends. One end which is connected to the planet gear, and second end which rotates about the axis of the sun gear. Planet gear which rotates about its own axis as well as it rotates about the periphery of the sun gear. That's why this is called as the epicyclic action. That means one gear which rotates about the periphery of the another circle, which is called as the epicyclic action, and so that's why such type of gear pairs or gear trains are called as the epicyclic gear train. Now we use now we'll study how to use the tabular method to do the kinematic analysis of this epicyclic gear train. Now in this case we have to consider the three conditions. We'll study each condition step by step. Now in this case, while doing its analysis, in the initial condition we need to consider that arm is fixed. Arm C is fixed. When this arm is fixed, and if we allow to rotate this gear A in a clockwise direction, which allows to rotate gear B in the anti-clockwise direction. Okay, when arm C is fixed and gear A completes plus one rotation, that means in this case I will allow to rotate the gear A to complete one rotation. That means in this case that NA is equal to plus 1. That means it rotates in the with the one rotation in the clockwise direction, and that arm is fixed. That means speed of that arm which is 0. NC is equal to 0 and NA is equal to 1. Now we know the velocity ratio, that NB upon NA or NA upon NB. Here we are going to consider the NB upon NA. NB upon NA is equal to TA upon TB. That's why, and that just wait, I will just mark that. Okay, now that NA is equal to plus 1, that this NA becomes the plus 1. That's why NB is equal to TA upon TB. Okay, but in this case we need to consider the signs. Here we have considered the plus 1 rotation. That means for the clockwise direction we are considering the plus 1 rotation. That means for the anti-clockwise we have to consider the minus. Now gear A and gear B, this gear A and that gear B are the external meshing. For the external meshing, both the gears are rotated in the opposite direction. Hence, for when gear A rotates in the clockwise direction, gear B will move in the anti-clockwise direction. That's why here up to this we have to just consider the we have just calculated the magnitude. Now we have to consider the magnitude as well as the direction. That's why here we have to consider its direction minus, that means which is the anti-clockwise direction. Okay, now this gear A completes which rotates in the clockwise direction, and that gear B which rotates in the anti-clockwise direction. Okay, now this is the condition 1 in which we get NB is equal to minus TA upon TB. This is the, that means for the condition we can find out the speed of the all three members, rotary members, in which NC is fixed. That's why its speed is of 0. We are allowed to rotate that gear A with the plus 1 rotation, and by using that we can find out the speed of that gear B, which is the NB is equal to minus TA upon TB. Next, now In the second case, that arm C is fixed again, just like the previous condition 1, that arm is fixed, arm C is fixed, and gear, instead of +1 rotation, now it completes the plus x rotation. That means NC is equal to 0, NA is equal to plus x rotation. That means plus x means the clockwise direction. Now you have the choices. You can take that, that means plus means for the anti-clockwise also. According to that, your sign gets changed. Ultimately, you will find the same answer, same directions. Now Na is equal to plus x. Now if we take the ratio of again Na upon Nb or Nb upon Na is equal to Ta upon Tb, again that Na is equal to plus x, that's why Nb is equal to Ta upon Tb into x. Again both the gears having the external meshing, that means both are rotated in the opposite direction. That means when gear A completes the plus x rotation in the clockwise direction, according to their teeth ratio, according to that we can find out the speed of the gear B, and that direction is the anti-clockwise because it rotates in the, because of the external meshing, it rotates in the anti-clockwise direction. Now we have to consider the third condition. Now that arm is moving with or rotating with the plus y rotation. That means now we need to add the plus y rotation of the arm. That means NC is equal to plus y. Now arm C rotates which adds plus y rotation in the speed of the gear A and the gear B. When we allow us to rotate this arm C, which adds the plus y rotation in the gear A as well as in the gear B. Now we will just consider, now we have considered the three cases, that first three conditions. In the first condition, arm is fixed and that gear A, that means input gear, completes the +1 rotation. In the second case, that arm is fixed and that gear A completes the plus x rotation, and in the third condition we need to add the y rotation of the arm. That means we need to give the rotation to the arm. Because of this, what happened? Now in this case, this is the table. Now this is the table that you need to draw every time, and you have to put these values or put this equation in the same manner. Arm C is fixed and gear A completes the +1 rotation. Okay, again with the, that arm is fixed, that's why it's 0. Gear A completes the +1 rotation, that's why +1, and gear B, which rotates in the anti-clockwise direction, and its velocity ratio which is of Ta upon Tb, that's why it is of minus Ta upon Tb because it rotates in the opposite direction. Now instead of this +1, you need to multiply all the equation by the x. We'll get 0 x minus x Ta upon Tb. In the third condition, we need to add the plus y rotation. That means here we have to just add the plus y plus y plus y, and you, in the last, you need to make the addition of second step and the third step. In the second step, which is the y, in the, for the gear A, which is of x plus y, and for the gear B, which is of y minus x Ta upon Tb. Using this, you will get the speed of this gear C, gear A and the gear B because of that epicyclic action. That means NC is equal to y, NA is equal to x plus y, and NB is equal to y minus x. So y minus x Ta upon Tb. Now in this case, in the same fashion, you will find the numericals. Sometime that speed of this NC will be given to you, speed of this NA will be given to you. You have to find out the speed of NB, or that NB is fixed. Sometimes they may be given that NA is fixed or the NB is fixed or the NC is fixed. Any one condition will be given to you, and according to that you have to find out the speed of the remaining gears. Now we'll solve one numerical over here. Now we'll consider some cases in case of this simple gear train, simple epicyclic gear train. This is one gear train in which that input A is fixed, that means gear A is fixed, and gear C, gears, that means arm C, which completes the +1 rotation, and we have to find out the rotation of the gear B. In this case, that rotation of that gear B is equal to 2, that we have to satisfy, that we have to check using this tabular method. That NC is equal to 1, speed of this arm is equal to 1, and speed of this gear A, which is fixed, that's why NA is equal to 0. Now we have that table. I have just considered this same table from that uh, previous slide, that NC is equal to Y. Again, in this case, for the better understanding, we'll consider here we'll consider the number of teeth on the gear A and gear B are same, is equal to 32. That means we need to satisfy this. That's why we are considering the same number of teeth. Now we know that NC is equal to Y by using this table, that NC is equal to Y, but NC is equal to 1. Okay, again that NA is equal to X plus Y and NB is equal to Y minus X TA upon TB. But NC is equal to plus 1. That means NC is equal to Y is equal to 1 if you consider these two equations. Again NA is equal to 0. In this case NA is equal to 0, but NA is equal to X plus Y is equal to 0. That's why X is equal to minus 1 minus Y and Y is equal to 1. That means X is equal to minus 1. Now we need to put these values X, that X is equal to minus 1 and Y is equal to 1 in this equation, and if you put these values in this equation, we will find NB is equal to 1 minus 32 upon 32, because TA and TB are given to you. Minus minus becomes plus, and that's why that B is equal to plus 2. In this way we can obtain the more than one gear ratio, though they are having the same number of teeth. If we consider this is the simple gear train, simple gear pair or the gear train, in that case that gear ratio is of 1, but because of that epicyclic action we will find that gear ratio speed of that gear B, which becomes the 2. This is the beauty of this. Now we will consider the second simulation, in which that gear A completes the plus 1 rotation, that arm C is again completes the plus 1 rotation. That means both are rotated in the clockwise direction. NA is equal to 1, NC is equal to plus 1. By using this table, that arm C is equal to Y rotation, that means NC is equal to Y, NA is equal to X plus Y, NB is equal to Y minus X TA upon TB. Again here also again we consider this, both the gears having the same number of teeth. TA is equal to TB is equal to 32. NC is equal to plus Y, NA is equal to X plus Y, and NB is equal to Y minus X TA upon TB. Now NC is equal to plus 1, which is given. NC is equal to plus 1. NC is equal to plus 1. Again if we compare these two, that Y is equal to 1. Again NA is equal to 1 and NA is equal to X plus Y. That's why that X is equal to 1 minus Y. But that Y is equal to 1, that means X is equal to 0. That means X and Y are known to us. X is equal to 0, Y is equal to 1. If you consider this equation, that NB is equal to Y minus TA upon TB into X. X and Y are known to us, TA and TB are known to us. If you put these values in this equation, you can find NB is equal to 1. We can achieve the same velocity ratio, same velocity as that of the gear A and the arm C, which is the NA is equal to 1. Now we will consider the next condition, which is the third simulation, that NA is equal to minus 1 when we allow us to rotate gear A in the anti-clockwise direction and that arm C in the clockwise direction. NC is equal to 1 and A is equal to minus 1. Again both the gears are having the same number of teeth. TA is equal to TB is equal to 32. Again NC is equal to Y. Again we have to consider the same table. NC is equal to Y, NA is equal to X plus Y, and NB is equal to Y minus X TA upon TB. But is that in this equation or these conditions are given, NC is equal to 1. That's why NC is equal to Y is equal to 1. Again second condition, NA is equal to minus 1. That means X plus Y, NA is equal to X plus Y is equal to minus 1. That means that X is equal to minus 1 minus Y. Again that Y is equal to 1. That means X is equal to minus 2. If you put these values, that NA, Y is equal to 1, Y is equal to 1, again X is equal to minus 2, T and TB are known to us. If you put these values, we will find that speed of this gear B, which is of 3. That means the speed of gear B, which is the 3 times of the speed of that gear A and the arm C. That means heavy increment in the speed or a decrement in the speed we can achieve using the epicyclic gear train. This is the one of the beauty of this epicyclic gear train. With the same resources we can achieve the different velocity ratios in the epicyclic gear train. Now we'll come to the end of this session. In this session we learn how to use the tabular method. We have considered different conditions for the simple gear train to achieve the different velocity ratios. From this we come to know that using this epicyclic gear train we can obtain the, or we can, in the very compact space we can increase or decrease heavy reduction or the increment in the speed of that output gear can be achieved in case of epicyclic gear train. And this knowledge will be helpful to the students, and with that they can do the design of gear train or the gearbox for the industrial and the automobile application. With this I'll finish my session over here. Thank you for patient listening. Thank you very much.